Okay, so before we begin, I wanted to quickly introduce myself. My name is Alexandra Sims. I'm going to be the host for this session, and I'm also a co-organizer of Jay and the Beach, along with some other really cool people I get to work with. I am not a tech person by training, but I am a tech enthusiast, and I have a soft spot for everything that's related to technology, as well as my little dog Amigo, who's been keeping me a lot of company while I've been on lockdown in the last 4 weeks now, I think. So why are we here today? The purpose of Jay on the Beach is to create a space where people can exchange knowledge. And as a purely technology-driven event, we weren't going to let our community down during this time. It's at our core and part of what makes us who we are at this event, the people who organize it, and our community, which is made up of you, developers that support it. So we decided to use technology and all the means we have available to get together, even if it was at a distance. Plus, we're all supposed to be at home anyway, right? So it's better that we do something with our afternoon and have a reason to get together and see each other. So we've organized a series of virtual events, and for now we have something planned for April, May, and June, and we're even considering organizing a few more sessions until we get to see each other in person in October. So looking forward to seeing all of you in the upcoming events. I'd also like to give a special mention and thanks to our sponsors who continued their support and their commitment to the event, regardless of what date we're going to be able to celebrate it. And to all of our attendees who have maintained their enthusiasm and are still coming to the event in October, we're really, really looking forward to seeing you. And then on the same note, we can't forget our speakers who remain committed to Jay on the Beach. Not only are they still accompanying us during the physical event, but they're going to be with us during the lockdown sessions like the one we're hosting today. So lastly, I do want to encourage everyone who hasn't yet purchased tickets to the event in October. It's going to be October 14th through 16th, and you're still on time to get tickets at the regular ticket price. We had planned to raise the ticket prices in April, but due to the current situation, we're going to wait until July. So this is the perfect time to get them. Make sure to run, get them quick, because we really want to see you in October in Malaga, close to the beach. It's still very good weather during that time. And so without further ado, I want to get the quarantine session started. We are going to have 4 speakers who I will introduce at the beginning of each talk. Today we have with us Natan, Marta, Alex, and Nadi. They're each going to have 20 minutes for presentations, and then we'll have 10 minutes for questions. Please feel free to write any questions that you have in the chat. Myself and my colleagues who are also on the line are going to help monitor them so we can make sure we can answer as many questions as possible. And if you're enjoying the session, if you want to talk about us on LinkedIn, on Twitter, or whatever social media platform that you're using, please tag us. You can find us on LinkedIn, and you can also use our Twitter handle, JOTB2020, and just use our hashtag virtualJOTB20. So I think if we're all settled, then I'd like to introduce Natan Silnitsky. He is a back-end infra engineer at Wix.com, and his passions include clean code, functional code, dev velocity, and great software design. So Natan, if you are ready, I'm going to go ahead and let you take it away.
So welcome everyone. My name is Natan Silnitsky, and I'm a backend infrastructure developer at Wix.com. And I'm part of the team that is building all kinds of tools and libraries on top of the Kafka message broker. And recently, we've started using the exactly once semantics and incorporating it into our distributed system. And I thought it would be a great opportunity to share with you how Kafka implemented exactly once delivery and why is it hard to achieve. Okay, so at Wix we have a distributed system, and it's comprising around 1,400 microservices. And we have all kinds of event-driven flows, including site editing and site publishing, as Wix is a website building platform. And we produce around 1 billion messages to Kafka every single day. Now, in order to understand the difficulties with exactly once delivery, I wanted to demonstrate the problem with a classic e-commerce flow that everyone is familiar with. So we're starting with a payment service, and we're notifying the checkout service that the purchase was completed. And now we want to update the inventory, but the inventory service has some legacy API where each item needs to be updated separately. So once the items arrive to the inventory service, it will update the database and the actual inventory. Now, this can be quite problematically to achieve exactly once. There could be some failures and then restarts for the whole updating inventory process. So let's say that we manage to update the first item, and then we manage to get the request in for the second item, and then for some reason, during the request, the second request, there was some failure or restart or something like that, and we probably want to retry to make sure that the inventory service got all the items. So what will happen here, that there's a chance to get incorrect data into the database by the inventory service because of these retries. So what can we do to mitigate this situation? We can maybe use some database to handle our update versions and make sure that each time we assign a version to each update request and make sure that there's no double processing. But that's all on the application level. But what we really want is to have the infrastructure deal with all this stuff for us, right? So we can see that achieving exactly once delivery is not easy to achieve on distributed systems. The message delivery over the network is unreliable. And we can introduce a message broker between our microservices in order to help a bit, because we know once a message is inside the broker, our intermediary, we know that it will never get lost. But this is still not enough. But first, let me do a quick intro on how the Kafka message broker works for those of you who are less familiar with it. So we produce messages to specific topics, and these topics are divided into specific partitions. And each partition is basically an append-only log. So the producer will produce the message at the end of the partition, which means you have sequential processing, and it has much better performance because we can lift up the partition usually in memory, don't have to access the disk all the time. And if you want to scale up and have much more parallel processing, all you do is spin up more and more partitions. So it's really easy to scale up with Kafka. And here we see an example of Kafka producer producing the message to the end of the partition. And then the Kafka consumer processes and reads the partition sequentially. And here we can see that it's currently processing message 3, the offset 3, and it has already committed the messages 0, 1, 2. So it's not like the Kafka consumer removed the messages from the partition like a message queue. They are still there. It just committed them. So if there will be some restart for our service instance, then the Kafka consumer will pick up from the last message offset that has yet to be committed. So in this case, if there'll be a restart now, it will again process message from offset 3. Okay, so that was a very quick intro into how Kafka works. I hope you were able to follow for those of you who are less familiar with it. And now I want to go over the different options we have for message delivery. So we have 3 basic options: at least once delivery, at most once delivery, and exactly once delivery. With at least once, we want the producer to make sure to have the message arrive at the partition at all costs, meaning that it will retry on every failure. And in this situation, we may end up with duplicate messages on the partition. So the service will need to address that and deduplicate. Now, over on the consumer side, with at least once, we want to make sure that every single message is processed at least once, right? So what we'll do, we'll first process the message, and only once we finish, we commit it. That means that if we need to retry on some failure, we can end up with multiple processing of the same message. So we need to make sure that we handle that correctly. Now, with at most once consuming, we actually flip it around. First, we will commit to the Kafka broker the partition, the message, and only then will we process it. That means that we may end up with losing some messages, because when we first commit the message and then for some reason the instance restarts or there's some failure, then we recover, it means that that message is no longer available for us. It's already committed, and we go over to the next one. And this is very useful in cases where you really don't want to have double processing. One use case you can think about is when Wix sends SMS messages over to its users and has all kinds of reminders for stuff. And we don't want to bother our users with too many reminders or even duplicate reminders of the same thing, right? So, and we don't mind losing some reminder here or there, but it's really important not to get too many duplicates out for our users. So this can be a good use case for that. But what we really want is exactly once delivery. We want messages to be read and processed exactly once by the consumer. That's really what we want, but that's really hard to achieve. And now I would like to share with you a thought experiment as why exactly once is difficult, even in theory. So there's a famous thought experiment called the two generals problem. And we have here two generals, Alice and Bob, and they're trying to coordinate an attack against the shared enemy. The problem is the enemy is lying between them. So Alice tries to coordinate and sends over a messenger with the time of the attack over to Bob. But it could happen that the messenger will be intercepted by the enemy that's between them. So then Alice will send another messenger over. And let's say that this time the messenger has arrived over to Bob. And then Bob will send over a messenger that he agrees to the time of the attack. Good. And let's say even that the messenger that acknowledged the time of the attack arrived at Alice well. But how will Bob know that the messenger has arrived to Alice in one piece? Should Alice send a messenger that acknowledges the acknowledgement? You can see that we're kind of entering an endless loop here of acknowledgements. So it actually means that we can't really have the two sides agree on the time of the attack in a meaningful, not endless way, right? So it's the same situation we have with our microservices environment. We have our Alice service that's trying to send a message over to Bob's service over some unreliable network that can be the enemy, or some hardware failures, or the Kafka message broker can be down. So Alice will have trouble guaranteeing that the message has definitely arrived at Bob's to acknowledge the message passing in a single time. So that's the issue that we have with exactly once delivery, theoretically. But maybe Kafka does have a solution for this, and that's what we're going to see now. So we're going to see Kafka's exactly once semantic solution using this classic event-driven flow. We start off with an HTTP endpoint request over to the first service. Then this service is going to produce a message to topic A with the contents of the request. And in the middle, we have a service that acts both as a consumer and a producer. And so we call it a processor, that it consumes the message for topic A, does some processing, and then produces it over to topic B. And at the end, we have another consumer that consumes the messages from topic B and will be able to observe the messages. That's why we call it an observer, and it will perform some side effect outside of Kafka towards the database storage. So that's the flow we're going to use. And we'll start off with introducing exactly one semantics to the producer. So if you want the producer to be exactly once, we actually want to have some idempotency when we produce. Idempotency means that no matter how many times we perform the action, then the state will not change because of that. So if we enable idempotence in the Kafka broker for this producer, it means that the producer will assign the offset of the message, the index, to each and every message, meaning that the broker can easily see that a message has already been produced and discard it as a duplicate. Okay, so idempotent producer is quite simple to implement, but here it's a little more tricky for the rest of the flow. Actually, what Kafka will do, it will create a transaction between the processor and the observer, such that only once a transaction is committed will the messages will actually be observed and handled by the consumer or observer. So what goes on behind the scenes here? We'll need to attach an offset to the message for exactly like the producer at the beginning does. And we also want to mark the beginning and end of the transaction. So in our code, of the client side, on the service, we call the consumer poll. And then we mark the beginning of the transaction. And then we can send over the first message of the transaction, in this case, message C. But not to forget also to send the offset of the message, in this case, offset 2. And then we can, if we don't send the offset, we can't handle duplicates well, right? And then we commit the transaction, and only once we commit the transaction, observer can start seeing the messages from the transaction, which is message C, and process them. Now, maybe we failed to send the offsets for message C. Maybe the processor got stuck or something, or got a restart. In that case, when the processor service will resume, it will understand that there was a transaction going on in the middle before that, and it will be able to abort the transaction and start from scratch. And the observer still doesn't see message C because no transaction has yet been committed. Now, there's another issue here with the throughput performance, right? Because we saw an example where we send one message and we have all this overhead of the transaction. So we want to maybe amortize the cost of the overhead for the transaction and send as many messages as possible in a single transaction batch. But then we need to remember that the observer will only be able to witness the messages once this transaction is completed and committed, meaning that it can take time and latency until it can start consuming. So we end up with a trade-off here between higher throughput and higher latency according to how we tune the batch size for the transactions. And another very important note here is that we don't actually have a complete end-to-end solution for exactly once guarantees. We have the initial HTTP request, and so we have the communication with over HTTP, and there could be duplicates there, and we need to handle them, right? And recover from failures ourselves, not through Kafka. And also the side effect at the end, outside of Kafka, where we write to database, we also need to handle deduplications on the database itself when we do the application and the DB writes. So that's outside Kafka as well. And in reality, this is much more complex than how I described it. There is a two-phase commit procedure and a whole other entity outside of the broker. It's called a transaction coordinate that actually manages these transactions. It uses a transaction log to make sure that it knows exactly when the transaction, what step in the transaction, and if the transaction was aborted or not. And there's also additional fencing going on. Fencing of what? Fencing of zombies. What do I mean by zombies? Well, think about the situation where we have our service instance that's consuming and producing, and suddenly it gets stuck. So we spin up another instance, right, to do the processing for it on the same partition. But then suddenly the first instance comes alive like a zombie, and then we have two instances running on the same partition. So we need to make sure that the zombie does not interfere with the transaction. And Kafka introduces all kinds of other information like transactional IDs and epochs to fence against these zombies. And one final note about the complexity here is about resource utilization, because now a single processor producer can only handle a single partition, meaning that if we have more and more partitions, we'll need to use a lot more resources and threads. But Confluent, the company behind Kafka, is working on changing the design of partition rebalancing, etc., and making it work with these exactly once transactions. So let's go back to our earlier classic e-commerce flow and introduce the exactly once semantics over it. So first, we will produce the completed purchase order into Kafka, the Kafka partition. And then the checkout service can process the order complete and produce the update inventory requests over to the inventory service. And even though it's all in the same separate items, they can also be part of the same transaction. And they can be part of different partitions. They can be sent to different partitions or even different topics. They all be part of the same transaction. And then we can guarantee that the inventory service will get the entire inventory update event at the same time, at the same transaction. So to summarize, exactly once delivery is like the holy grail of message delivery over the network. It's a tough nut to crack. It's complex to implement, like we saw. It's quite complex to use. There are quite a lot of commands we saw that we need to use, and it will require fine-tuning, for instance, with the batch size. But it's crucial for achieving atomic actions in distributed systems, and we want the infrastructure level to solve it for us and not get bogged down with that boilerplate on the application level and the business logic. So thank you very much. I hope you enjoyed it. If you're interested in more information on the Kafka exactly once semantics and how it is implemented, you can check out the resources here. And you can check out, you can find all the links I shared on the slides in SlideShare. And you can follow me on Medium and Twitter to get any more updates on everything about Kafka and Scala and our implementation on the data streaming team at Wix and other things that we are up to. And now I guess we can have some questions if anyone has them. Right, Alexandra?
Hey, Natan. So I got a question here. It says, sorry, let me just read the chat. It says, do exactly once delivery guarantees, you can tell me if I'm saying this right, do exactly once delivery guarantees extend across Kafka clusters?
Right, okay, so that's a good question. So basically the exactly once mechanism that I described is contained to a single cluster, but you can take the observer logic that Kafka implemented and actually put it on the consumer on the other cluster. So that means you will need to implement a lot of the stuff that Kafka had with the keeping up to date with the offsets, etc., on the consumer side of the remote cluster. But it is doable, just not out of the box.
Okay. And then I'm just going to ask also, if you have questions, please put them in on the chat. You can send them to myself if you like, but it'd probably be better if you send it to everybody. That way everybody can see the questions. But I have one more question here. It says, what other use cases do you use exactly once delivery for at Wix?
Oh, okay, yeah. So at Wix, we're currently introducing the exactly once mechanism, and we also have compacted topics that we use from Kafka, meaning that you can use Kafka not only as streaming messages, but also as a storage capability of key value stores. So we use Kafka as a storage mechanism, and we upload the messages over an in-memory key value stores. We read the stream from the Kafka topic. And the idea is that you can write messages over there, like updating a database, right? We want to update the value of the key, and we want to do it in an atomic fashion. So if you want to do an atomic operation of updating the key value store, in the process of introducing exactly once the semantics there, to make sure that each update to the key value store is done in exactly once manner, and so we know that our data is not corrupted.
All right, I'm going to unmute everybody for a couple of minutes in case somebody has a question and can't use the chat. Okay, so everybody has been unmuted now. This is your time to ask any other questions that you would have for Natan.
I think it's really early over in wherever it is people are. They must still be sleeping.
I think so.
Yeah, I think I have a question.
Yeah.
Yeah. Thanks for the nice talk. Yeah, I've used Kafka before, but it seems to be very difficult to configure. So I'm looking at a situation where you can use this for transactions processing, maybe like in a funds transfer system, like banking. So imagine if I was in the US today and I wanted to send paychecks, relief paychecks, electronic checks, and I want to avoid duplicates. So I'm looking at a situation where I need to use Kafka to pay off these people, or imagine, for example, securities trading, where people are buying and selling stocks. So can this only once delivery be used for this kind of scenarios, and what are the drawbacks?
I was a bit hard to follow you, so can you please again repeat the scenario that you're thinking about for exactly once semantics, but maybe a bit slower because I have maybe a bad connection, I'm not sure.
Okay, sorry about that. So I said, imagine I had to pay, send some relief checks to people
Tens of millions of
across the U. Yes, across the US, as regards to alleviating their pains on Corona. So I want to ensure I send the checks only once, because any duplicate check will means that that person could be receiving the money more than once. So that's leakage for me. So also imagine that I'm doing securities trading. I'm trading stocks on NASDAQ. Yeah. Can this exactly once be used, just so that once somebody picks on the stock, is gone, and it depletes the pool accordingly without any issues around double purchases and all that?
Right. So that's a great example when you want to work with numbers and accounts, and you want to like make sure that you update reduce the number and increase the number and make sure that it stays consistent, right? Because if we have duplicates, we can, like stocks or sending checks, then we can definitely get into trouble with regulations and all kinds of stuff like that. So Kafka, exactly once infrastructure can definitely help you get there. You still need to do a lot of work, like I showed, before you enter into the Kafka brokers and system, and when you get out of it. But it can definitely get you there faster and sooner than needing you to do all the work yourself with, like I mentioned in the beginning, creating the database tables that make sure that you only process stuff once, and there's optimistic locking and pessimistic locking that will hurt your performance. So Kafka will have a better performance for you and will make sure that you do it with much less boilerplate.
Okay.
Thank you for your question.
Yeah, thank you.